Hello everyone, welcome back to PMAC1140. So we just finished chapter 6, and today we're going to jump to chapter 7. And in this chapter we talk about the concept, and this concept it belongs to a different branch of mathematics. Is totally different from what you guys been studying, you guys been learning. And this concept it belongs to a different branch of math. We call that branch of math we call the linear algebra. And the concept I'm talking about here is matrix. I don't know if you guys will go to another higher level math, but if you go to another high level math, then you know that linear algebra is the foundation of mathematics. And because matrix is a concept of linear algebra, so matrix is considered as the foundation in mathematics. Then what is matrix? Maybe some of you already watched the movie named Matrix, right? And in that movie you see a bunch of data processed by computer, right? And those data are displayed and stored in a structure format. Okay, that format is called matrix. Okay, so in this lecture I'm gonna start with section 7.4 first. I introduce what matrix is. In the new textbook it should be in section 7.4, but if you have the old one, 6th edition, I believe that in the syllabus I require the 7th edition. It should be in section 6.4, but in the new one, the 7th edition is 7.4. So we start with section 7.4, then we go back to section 7.3, then we jump to 7.5. Okay, and finally we're gonna do section 7.6. Okay, so let's start with the lecture today. So on the first part of our lecture, I want to introduce what matrix is, and the first moment we're going to talk about the definition of matrix. Okay, so let's put the topic for this section today, section 7.4. We talk about a matrix and its algebraic operation. Okay. So on the first Roman, I want to talk about definition of matrix. Matrix is the data, okay, but it's stored in a structure format. So I can say that a matrix is a rectangular array of number, okay, that are arranged into row and columns, and this number of row and columns we call that the dimension of matrix. So the matrix can be notated as the number of row. I can notate it as the M, okay, and the number of columns is n. So I can say matrix M by n. So this is the notation representing a matrix m by n. Okay, so this matrix over here contain m number of row and contain n number of columns. Okay, so this is called the dimension of matrix. Okay, so all of this is the dimension of matrix. Okay, all right. So this m is represent the number row and n represent the number of columns. Okay, so I can give you a quick example of matrix. For example, in this matrix, I have 2 rows and 3 columns. So I have because this is a array of numbers, so we have a 2, 7, 5, 4, 6, 9. So how many rows we have? We have a first row, second row, right? And we have 3 columns. So this matrix is 2 by 3 matrix. The dimension 2 by 3, 2 rows and 3 columns. Okay, so this is typical example of matrix, and each number in the matrix we call the entry. So each of them, each number here, we call the entries of matrix. Okay, it's usually notated as AIG. Okay, if I don't want to use number, I can use A sub IG, and with I is the row. Okay, row, I is row, so I could be from 1 to m. Okay, I is row, and J, so this is row, right? Because m is row, and J is column, so it could be from 1 to n. This is column. I just want to make sure that it's really horizontal. So it means columns. Okay, so the entry number 2 over here is the first row and the first column, right? So this belongs to the first column, and 2 also belong to this first row, but because row go first, so number 2 number 2 actually is A11, first row, first column. So A11 sign is a sign number 2. Okay, and number 7 is assigned to A first row, right? First row, second column. So A12, and so on. So number 5 will be what? Number 5 will be first row. First row will be 1, 3, A13. Okay, so row go first. You see, because over here, I over here is 1, is row, but number 5 belongs to the third column, so it's A13. Okay, and a matrix is classified by its dimension. Okay, matrix is also classified by dimension. Okay, so if you have a matrix n by n, you have matrix n by n is a number of row equal the number of column. That's what I mean. We call this matrix a square matrix. I can give you example. Example is for example, I have over here matrix 2, 3, 4, 5. So this is a square matrix because then we have 2 rows and 2 columns. If the number of rows equal the number of columns, then that matrix is a square matrix. Okay. If we have only 1 row but n column, okay, then we call that a row matrix. Okay. If we have m row but 1 columns, then we call that columns matrix. Okay, for example, I have matrix 1, 3, -4, 7. Okay, so this is a row matrix. An example of the column matrix, you put everything in columns, so it could be 4, -5, 1, 8, for example. So this is a column matrix. Okay. And 2 matrices can be equal to each other. Of course, if the 2 matrices equal to each other, then the number of column of the first matrix should equal to the number of column of the second matrix. So is the row. Okay. Other than that, the entries of those 2 matrices must be the same also. Okay. So let's talk about equal matrix. If they have the same dimension, you know, the same number of row, the same number of column, and corresponding entries, as I say, the entry must be the same, are equal, then those 2 matrices are equal. For example, I have matrix A, so I name it the matrix A. They have let's put this 3 row and 2 column. Okay, 3 rows, so we have 2 columns, 2, 4, 6, -3 and 2. So I have matrix A is like that, and I have matrix B. It's the same, exactly the same. Then I can conclude that matrix A equal to matrix B. Okay. If one of the entries different from the other, then those matrices are not equal to each other. Okay. And you see that all the matrix here is nothing but a rectangular array of number, and we already know that number we can add or subtract, we can be divide, it could be or multiplying. So let's see if we can do those operations on matrix or not. Okay. Let's say we can multiply, we can add, or we can subtract matrix or not. So on the second part of the video of the lecture today, I want to talk about algebraic operation on matrix. Okay. But before we talk about adding or subtracting matrix, let's talk about dimension first. Okay, over here we already talked about dimension. Where I mentioned dimension when we have equal matrix. But for the second part, let's talk about more about dimension of matrix. Let's see if it has different dimension, can we add matrix or not? Or if it has same dimension, can we add the matrix or not? Or just one case or the other. Okay. So And let's given matrix A and B, and I say that these two matrices here have the same dimension. It means the number of row and the number of columns of the first matrix A equal to number of row and the number of column of the matrix B. Okay. Then the sum, it means that we can add. Then the sum of matrix A and B is also a matrix with the same dimension. Okay, with the same dimension. I mean, whatever you have, matrix A is 2 by 3 and matrix B is also 2 by 3. Then after you add them up, it gives you the sum matrix also. Okay, but how are we gonna add it? How are we gonna add it? We add the entries. So whose entries is AIG plus BIG. AIG is the general entry for matrix A, and BIG is general entry for matrix B. Okay. Other than that, we can so add and subtraction. So the sum or the difference, it is also work for this one. The sum or difference. So I'm gonna just add it over here. Or it means that you can subtract two matrices. Okay. Similarly, we can also multiply a matrix by the number. We call the scalar product of matrix. So scalar product, okay, of a matrix is when you multiply a number, in this case a number k, k could be anything, could be negative or positive, by a matrix A. Okay, then you will have the entry of the new matrix will be, whose entries will be KAIG. Okay, it means what? It means that for each entry we multiply by K value. Okay, let's go through the example. Let's go through the example, and you know right away. What if I have a matrix 3 by 2, 3 by 2, 3 row. So let's name it. This matrix A is 3 row and 2 column, something like this. So this is 3 by 2, 3 row and 2 column, 3 by 2. Okay, it's 3 by 2 matrix. That's matrix A, and matrix B is also 103 by 2. Okay, so I have two matrices with the same dimension, 3 row, 2 column. Okay, now I want to add these two matrices together. So it gives you another matrix, and that the new matrix will be in the same dimension, 3 row, 2 columns. So we just add the entry. So AIG, BIG, so we add them up. 2 plus 1, 3, negative 3 plus 0, negative 3, 0 plus negative 3, negative 3, 5 plus 1, 6, 7 plus 2, 9, negative 1 over 2, plus 2 is 3 over 2. Okay, so you just add all the corresponding entry of each matrix together. Okay, and you can do for any type of matrix. You can add or subtract any type of matrix as long as it has the same dimension. Okay, as long as it has the same. If it is not the same dimension, then of course we cannot add. So for example, in this case, example 2, I have matrix C. Its dimension is 2 row, 3 column, 7, -3, 0, 0, 1, 5. So this is 2 by 3, and I want to add to matrix A. Matrix A is 3 by 2. Okay, so 2 by 3 add to 3 by 2, we cannot add it. Excuse me. we cannot add it because the dimension doesn't it's not the same, undefined. So you cannot add it. It doesn't work. Okay. How about scalar of the matrix? Example 3. I want to multiply matrix B by 2. So 2B, it gives you a matrix. So 2B is a new matrix. So multiply by 2, it means you multiply each entry by 2. So 2, 0, -6, 2, 4, 4. Okay. So that's the way you do scalar product of a matrix. Very easy. Okay. So you already know adding, subtraction, multiply by a number. How about multiplication two matrices together? Can we do multiplication between two matrices or not? Okay. The answer is yes, we can. However, they had a condition. It had a condition, and otherwise, if it does not satisfy this condition, then you cannot multiply those two matrices. Okay. Then what is the condition? All right. What if I have so I'm gonna put a star right here because it's important. Multiplication of matrix. So what if I have matrix A, and matrix A, the dimension is m by n, m row and n column, and I want to multiply by matrix B with dimension is n row k column. Okay. So if you notice what I just written down, you see that the number of column of the first matrix is equal to the number of row of the second matrix. Okay. So as long as you satisfy this condition, then you can multiply matrix A by matrix B. Okay. Then when you multiply that, you will have a new matrix. Okay, you will have a new matrix. Then it will become matrix AB, and the matrix AB will have dimension m by k. Okay. I say matrix A by matrix B. Okay, multiply by matrix B. I didn't say matrix B by multiply by matrix A, okay? Because it's different. You know, in the classical algebra, you already learned that 2 times 3 equal to 3 times 2. It's a commutative property of number. However, in matrix, we don't have commutative property. It means matrix A times matrix B, it is different from matrix B times matrix A. Why? Because matrix, first of all, in this case, you see I wrote a matrix A times matrix B, we have the number of a column over here equal to number of row here. Okay, but if I switch them, So what do you see? You see the number of column here, which is k, and the number of row here is m. It is not the same. So if I multiply this, it does not work. You can't. So matrix, we don't have commutative property. Okay, we're going to talk about commutative property, not a commutative, when we talk about all properties soon after this example. Okay, well, what if I have matrix A? And matrix A, they have the dimension is 2 by 2. 1, 3, negative 1, 0. And I have matrix B. It's 2 by 3. Is negative 1, 5, 2, 0, 4, 7. Okay. Can we multiply A and B? The answer is yes, because the number of columns of matrix A and number of row of matrix B is the same. So I'm going to put in red color. I just circle. It is the same. So when I multiply, the answer will be matrix AB will be in dimension excuse me 2 by 3. Okay, so it'll be this and this. We're gonna take this row and the last column. Okay. All right. Excuse me, I'll be back. It's kind of cold around here, so so I have a very bad allergy. So, alright, try to get a blanket. Alright, so the answer of this product will be we'll have dimension 2 by 3. Okay, yeah, dimension 2 by 3. But how are we gonna multiply them? How are we gonna multiply them? So this is the process of multiplying matrix. Okay. You're gonna take the row, you multiply by each column. Multiply matrix is multiply row by columns. Alright, so let's see what I have. So you're going to have matrix 2 by 3, right? So let me open it. So the new matrix A times B will be 2 by 3. So let's multiply row by column. So this is how you do. Okay, so you're going to multiply row by the first column. First row, first column, first row, second column, first row, third column. Then second row, first column, second row, second column, second row, third column. Alright, so first row, first column, it gives you the first entry. The first entry A11. Then first row, second column will be A12, right? Row column A12. Then A13, first row A13. So over here will be A11, A12, A13, A21, A22, A23, right? So the first entry A11 will be, you're gonna do this. First row, first column. So you're gonna take the first number. So you take 1 times negative 1, 1 times negative 1, plus always addition. Okay, 3 times 0. Okay, so you're gonna follow this pattern. So 1 times will give you negative 1. Alright, so A11 will be assigned to negative 1. How about A12? So follow the same pattern. So 1 times 5 plus 3 times 4, which is 17. Okay, 17. Then 1 times 2 plus 3 times 7 give you 23. And you do the same for the second column, you will have 1, -5, -2. Okay. So the new matrix, the product of matrix A and B will be the new matrix, and -1, 17, 23, 1, -5, -2. Okay. Actually, the process of multiply row by column over here is a row by column over here. Actually, we call that the product right over here. We call that inner product. We call it inner product. Okay. So A1 over here, A1, B1, A2 plus A2, B2. You see that? A1, B1 plus A2. So this process over here, the process over here, we call the inner product. Okay. So inner product is A1, B1 plus A2, B2 plus AN, BN. See the process right here: A1, B1, A2, B2. Okay. What I have over here, we have a specific name for that. We call inner product. All right. Actually, this is you already learned in trigonometry. In trigonometry, I'm sure that you already learned this. A1, B1. When you're dealing with vector, you know the first vector you multiply by the first vector and the second vector. When you multiply two vector, the dot product, dot inner product. That's what I mean in vector analysis, in vector notation. Okay, when the first time you introduce two vector into trigonometry. Okay. So based on the example above, we see that we cannot have associative, we cannot have commutative property for in matrix. We don't have it. However, because we can add or subtract and we can multiply in a certain with certain condition, then it means what? It means that we still have associative property or distributive property. So over here on, I think I should because I already have over here. So on the next star, so the first star is multiplication. This next star over here, I want to talk about property of matrix. So the first star is multiplication of matrix. Okay. So because we can multiply and we can add, so if we have a matrix A multiplied by the sum of matrix B and C, then we have the distributive property. So we A times B plus A times C. So this is a distributive property. Okay, and of course we also have associative property, because of A times B C will be AB times C. So we does not change. You see, we does not change the order. Only the parentheses, the position of the parentheses change. So this is associative property. So we also have it. However, I already mentioned that we don't have commutative, because A multiplied by B is different from B by A. So no commutative property. Okay, no commutative property. Okay. Of course, we can multiply a matrix A by a number, so that means that's easy. You multiply matrix A by the matrix that is. I don't want to go too much into linear algebra, so I don't want to mention more about property of the matrix. So that's all you need to know in this course. Just know that you can A times B it's different from beta mate. Okay, it's not the same. Yes, it's not the same as you already learned. 2 times 3 but equal to the 3 times 2. In matrix, it's different. Okay, so in the next section, so I'm gonna stop section 7.4 over here. In the next session, we go back to section 7.3 and we try to see how we're gonna use matrix in solving linear system of equation, and how we're gonna create a matrix equation that help us to solve a linear system of equation. Okay, please go ahead, go through the example. Let me know if you don't get anything in this lecture, then send me a message and I'll see you next time in the next video.